Here are the things I'm going to cover in the video. Let's talk about setting up your jig. So a jig is a tool used to keep things in place while you're building your part. So using the original control arm, I built my jig from that to make sure everything is exactly where it needs to be. And once you get it tacked down, I used a nice flat steel surface, tacked it down, everything is held in place, and now I'm ready to begin building the tubular control arm in the jig. Now that my jig is ready, all set, solid, stable, and sturdy, the next step is going to be planning and setting up the part that I'm going to make. So these are the steel bushings that I'm going to use. I'm using as a basis in a plug for bushings. You can use polyurethane at the end, but you need to use steel so that you can weld and build from. So I'm setting up the steel bushings in here, and from that I'm going to grow the part from that point to the ball joint. Now that I have the bushings bolted down into the jig and I have an outline of the original control arm sketched out, I've machined the bushing down to fit within the dom tubing that's going to be used for the tubular control arms. Now we're ready to go. So the next step is going to be mocking up your parts for fabrication. So one technique I use is using cardboard or index stock to make my part. So cut a piece that's long enough and wide enough to fit around your tubing. And once you do that, you can wrap the cardstock around the tubing, and this will be your mock-up tube made of cardboard. And being made of cardboard makes it a lot easier to cut and shape and plan your tube without having to cut metal or waste material with cuts that were not good for you. So now that I made a tube of the index paper, I can use that to start planning lengths and shapes and angles that I need. Here I'm working out the angles, and you can see that I can determine how long my tube needs to be and things like that. So the next step is going to be coping and fitting tubes together. I know a lot of people have trouble with this because the tightness of your cope and fit determines how good your weld is going to be and how much material you'll use welding. So the first thing to do is to take your tube and divide it into quadrants, 4 parts. Half here, then draw a vertical line. It's perpendicular to, parallel to the length of the tube as possible. Then divide it into 2 more pieces so that you have four slices or quadrants. Once you do that, you can determine how much overlap you want your cope to have, your fish mouth. So now you line up one of your lines and determine if you want a 1/4 inch or 1/8 inch overlap on this tube. You will measure an 1/8 inch up this line and mark it. Now there's mark, you go to the opposite side and do the same thing. And now that you have your overlap mark, now you're going to connect that to the edge of the tube, and then we're going to cut that, and that's going to give you your fish mouth cope that will fit around your tube. Just make sure that you have your quadrants nicely marked. Draw your line down. And now I'm connecting the edges, and this is going to be my fish mouth. And I'm just going to cut this out with a zip wheel, and it's a lot faster than a coping saw, and it's pretty accurate. It's a technique, so it takes a little practice to be able to do it, but once you're able to do it, it's pretty quick and pretty easy. Now that I've cut it out, cleaned the edges so that it fits up against it, and now you can see how good of a fitment this is. So we gotta clean this. So yeah, you gotta clean up these edges, make sure that they're sharp so they fit around the tubing that they need to fit on. And like I said, this is pretty accurate and faster than using a tubing notcher. You can see how good the fit is, both sides, and now we're gonna get this welded up. So now that we have that welded up, I can start determining the length of tube I need and the shape and angle that I need to reach the ball joint. Now that I determine the first tube, the second tube I can determine its length and shape also. And I want good angles, and I need to make sure that it's going to be strong, so I'm figuring out what's the best angle, and also it needs to clear the wheel and some other suspension parts in the car, so I have to take that in consideration. So now you can see what direction it's going to go in, and once I have my tubing lengths and angles determined, I can start thinking about cutting it out of steel. And you can see I'm thinking about the angle and how this is going to match up to the base plate of the ball joint holder. So taking the tubes that we made and have the angles cut out, we slip this over your tubing, and that becomes your template. And you trace out, as I'm doing here, trace out the angles and shapes that you need to be cut from your metal tubing. And now I have that cut out, and you can see how that was used to form these angles and the length of tube. And I can tack this up for my first tube. Now working on the second tube, determine the angle there, and I'm using scissors to cut the index paper tube to make sure it fits effectively. I do the same thing with the second tube, slide the tubing template, the index paper tubing template, over the metal tube, and use that to cut out the angle that I need and the length that I need by marking it up and using it as a template. Now that I've found the angle in the second tube, I'm tacking it in place. And now that it's tacked in place, I am taking it off the jig and coping the end that meets up with the other tube. Using the same process of dividing my tube into quadrants, making a fish mouth, I coped it,
coped out,
and now it's
and
matched up nice
ready
and
to be
neatly.
tacked together.
And I'll
There'll be
tack
another
this
bar
up.
coming like this.
And you can see I'm working out the third tube
To
and how
reinforce
that's
it.
going to join to the base plate of the ball joint. And using the same technique, I'm going to take this template and use that as the guide for cutting out my metal tubing and the angles that are needed. And now that I have my tubes all tacked up using the same technique for all, you can see how this is coming together nicely with good structural soundness and strength. And once I have them all welded up, now it's ready to go. So next step is going to be adding grease fittings so that the tubular control arm can be greased without removing from the car. And I changed the design a little bit to add a little strength for the second prototype. And you can see the difference that what I changed. But using this grease fitting on this nut, I'm going to drill a hole into each arm's bushing carrier and put the grease fittings in using those nuts. So they can be removed and cleaned or whatever needs to be done in the future. Now they're all welded in. The arms are ready to go to be painted. Now that they're painted and ready to go, they're ready to be installed on the vehicle. Thanks for watching the video. Hope you liked it. Like, subscribe. There'll be more things like this. And follow-up will be how the car handles with the new control arms. So stay tuned. Come back and check it out. Subscribe so you don't miss anything.